Alright, so we are supposed to generate a Bode magnitude plot for the following transfer function, and then I added the extra question of what is the damping factor of the quadratic term, because last semester I had a lot of questions about that. So, to start with, we need to get it into the correct form. So I'll factor out from the top, I'll have 4 times 10 to the 4th omega squared, and then I'll factor out 100 from that quadratic term, so that I get 1 minus omega squared over 100 plus j omega over 2 over, and I'll factor out a 5 from that first term, and I get 1 plus j omega. And then from this second term, I'll factor out a j2 cubed. And I get not a j2 cubed, I will factor out a 200, thank you, yep. A 200 cubed. One plus j omega over 100 cubed. I don't think so, because I took out a 200, right?
So it's 200 plus j 2 omega.
Right, so I had j2 omega and I factored out a 200. And so the 2 canceled with the 200 and I got j omega over 100. Okay, so now I have 4 times 10 to the 4th times 100 over 5 times 200 cubed times 1 minus, and this is omega over 10 squared plus j omega over 2 over 1 plus j omega and 1 plus j omega over 100. And so let's see what that gets us. So that's 4 times 10 to the 6th over 5 times 8 times 10 to the 6th times 1 plus j omega over 2 minus omega over 10 squared over 1 plus j omega times 1 plus j omega over 100. So that's 4 over 40, so that's 1/10. So I think that ends up being 0.1. So that's point. Oh, thank you. And the omega squared on the top. And I was so proud of myself for being able to figure out that was 0.1. Okay, so omega squared. Now I want to look at the form of this thing and compare it to what I have on the first page, or not the first page, but so my quadratic zero is supposed to be of the form 1 plus j2 c omega over omega c plus j omega over omega c squared. That is the form for the quadratic zero. So that can tell me what my corner frequency is, and it'll also help me figure out my damping factor. So if I look right now, it looks like I don't have a j omega right here, but that's because I've got this minus. So I can rewrite this as 1 plus j omega over 2 plus j omega over 10 squared over 1 plus j omega and 1 plus j omega over 100. So from my quadratic term, so I'll start with my quadratic zero. I can tell by looking at this part right here that my corner frequency, omega c, is 10. Now to get my damping factor, I compare my middle term. I compare my j omega 2 to j2 c omega over omega c to figure out our damping factor, which is this funny Greek letter xc. So this is j omega over 2 equals j2 c omega over our corner frequency we now know is 10. So our j omegas cancel, and I get 1/2 equals 2c over 10, or 10 equals 4c, or c equals 10 over 4, or 2.5. So that's the damping factor. Okay, so we have a quadratic factor, a quadratic zero with corner frequency 10. We also have a zero through the origin of order 2. And I have a simple pole with corner frequency 1 and order equals 1, and a simple pole with corner frequency 100 and n equals 3. And my constant term was 0.1, and so I take 20 log, so 20 log 0.1 gives me negative 20. So my constant term is negative 20, so I'll draw that in red. I have a pole through the origin of order 2. So the pole through the origin of order 2, that goes through the axis at 1, and since it's order 2, it has slope 40.
2 or higher, is it always 40?
No, if it's order of 3, it would be 60, and order of 4 would be 80, and so forth. And we have order 3 coming up. And then we have a simple pole with a corner frequency 1, and so that has a slope of -20. So it's 0 until we get to 1, and then a slope of, whoops, oh wait, I messed up. This goes through 1, but on the axis right there.
So that is 0 to the origin, it doesn't mean that Jan point is that's the omega.
I'm sorry, say that again?
You're plotting 0 to the origin, right?
Yeah, that's the omega squared.
Okay, that
No, it doesn't matter. Yeah. And then, let's see. The pole, so the pole goes through 1 and then has a slope of -20. And then I have a pole, corner frequency 100, and it's order 3, so that has a slope of -60. Okay, so now when I start, I'm going to start at -60 over here. Let's see. Oh, I forgot my quadratic 0. My quadratic 0 no, you were right about the, you, hold on, 0 at origin of number 2.
simple pole, isn't the frequency 1 sometimes you change 1?
Yeah, I do, and I didn't change it 1. And it's not showing something on my solutions here, but okay, so then let me get my quadratic 0. So my quadratic 0 that has corner frequency 10, that one comes to 10, and then it's quadratic, so it has slope 40. and 10 is right there. And slope 40. Why is this one not showing 0? For some reason, I think it's just a mistake. I think the solutions that I got this from just left out the 0, the 0 to the origin. Yeah, I think I just left it out. Okay, so I would start at -60, and then I have a slope of, let's see, this pink line had a slope of 40. Was that right? Yes. And so I have a slope of 40. Until I get to 1. Did I not draw? I did not draw that through. I didn't draw my 0 to the origin.
When you draw this little response function, and you go to 1, you add 40 to the next, okay, then the next time we go at -60, like the one, so 1 add another 20.
I will answer your question as soon as I can pay attention. Right now I'm trying to fix my plot, so give me just a second. Because I messed up my zeros to the origin. Should have been right there. Okay, so what was your question?
Right. When you said like go to the response
Mm-hmm.
sections, you started at negative 60.
Yes.
And then you added 20, well, into negative, so if you did, like where do you plot this?
Okay, so when I get to, okay, so I'm starting at negative 60, and for right now I have a slope of plus 40. And so when I'm going to go all the way up to 20 when I get to 1. And when I get to 1, I now have added my simple pole. It looks like I'm about to lose. Could someone come plug this in for me? Thank you. And so when I get to 1, at 1 I had a simple pole that had a slope of negative 20. So now I have a slope of plus 40 and minus 20. So now I have a slope of plus 20. So I'm going to have that slope of plus 20 until I get to my next changing point, which is at 10. So I have a slope of plus 20. So from 1 to 10, I'll go up to 0. And then when I get to 10, I now have a quadratic 0, which has a slope of 40. So now I'm going to add my slope of plus 20 to a slope of plus 40 to get me a slope of plus 60. So I'm going to go up to 60 until I get to 100. And then when I get to 100, I had a pole of order 3 that was minus 60. So now that's going to minus 60 plus 60 gives me a slope of 0. Did that answer your question?
Yeah.
So where do you know where to start? Like how did I start at negative 60?
Because my constant term was negative 20, and then my zeros through the origin had a slope of plus 40. And so if it was goes through 1 and has a slope of plus 40, when I get to the next decibel back, it's going to be at minus 40. So I had a minus 40 here and a minus 20 that added together to give me minus 60.
So you just add up, or
I just add those numbers together to give me my starting point, and then my slope is the slope of that line.
and then what was the point of the damping factor?
It's because he asks that sometimes. When you get to controls, you'll learn more about what that actually means in terms of the oscillation and the damping of it, but I know that he's asked that before, so I just wanted to show y'all how to do it. It doesn't affect the plot at all. Okay, other questions?
When you have blue line, when you have 10, what's the source probably 60?
What's the question?
For the blue line?
Yes.
If you get to 10,
Yes.
is this slope positive 60?
I have the slope of positive 60 because I had a plus 20 and a plus 40 made a plus 60. Because I had a plus 20 coming into it, and then I added a plus 40 from the quadratic 0. Uh-huh. Other questions? All right. Well, if I were to do some videos, which ones would y'all most like me to do videos of?